Welcome back. Well, let's talk superheroes. Superman and Batman are racing to Santa Claus's house at the North Pole. Superman is flying at 230 miles per hour, and Batman's Batcopter is traveling at 200 miles per hour. Superman uses his supervision to see that he is 727 miles away from Santa's house, and that he's 966 miles from Batman, and the angle between them is 33 degrees. Who will sip chocolate with Santa Claus first? So first we're going to use the law of cosines to determine how far Batman has to travel to reach Santa's house. So if we want to find b here, the law of cosines says that b squared is 727 squared plus 966 squared minus 2 times 727 times 966 times the cosine of the angle between those two lengths. And then, so to find b, I just have to do the square root of all this goodness. So I can just bust open my fancy calculator, and I can do the square root of 727 squared plus 966 squared minus 2 times 727 times 966 times the cosine of 33 degrees. And I'm still in degree mode up here, so my answer should come out good. And enter. 532 point, and it says to round to the nearest tenth of a mile. So 532.7. 532.7 miles. Okay. Now part 2 is use distance equals rate times time to determine the time necessary for Superman to reach Santa's house. So Superman's distance, we're going to use distance equals rate times time. His distance away is 727 miles. His rate was 230 miles per hour. And we want to find the time. So we just divide by 230. And 727 divided by 230 gives us 3.16 hours. So this is going to take 3.16 hours. Part 3, we're going to use d equals r times t to determine the time necessary for Batman to reach Santa's house. So d equals r times t. Batman's distance away is 532.7 miles. He is going 200 miles per hour. So we just need to divide both sides of this equation by 200. 532.7 divided by 200 is 2.66. So 2.66, that means that Batman is going to take 2.66 hours to get there. So part 4 is to write a complete sentence that tells which superhero reaches Santa's house first and how much time he'll have to sip hot chocolate with Santa before the other arrives. Well, Batman is going to take less time to get there. So Batman's going to get there first. And then if we subtract 3.16 minus 2.66, we get 0.5. So he's going to get there 0.5 hours before Superman. So here is a complete sentence. Batman reaches Santa's house first, and he has about a half hour to sip hot chocolate with Santa before Superman arrives. So now we're going to solve this triangle. Part 1 is to use the law of cosines to find the missing third side. So we want to find this little b. Alright, well, little b squared equals a squared plus c squared minus 2ac cosine of theta. And in this case, A and C would be the sides that form the angle we're using, the angle that's opposite the side we're trying to find. So 6.83 squared plus 3.55 squared minus 2 times 6.83 times 3.55 times the cosine of 38.9 degrees. And then to find b, we would do the square root of all this. So now, making sure that I'm still in degree mode, I am going to enter in all of this stuff. The square root of 6.83 squared plus 3.55 squared minus 2 times 6.83 times 3.55 cosine 38.9, and we get 4.6381 stuff, but it says round to the nearest 100th, so 4.64. All right, so 4.64. So part 2 says use either the law of cosines or the law of sines to find the measure of angle C and round to the nearest tenth of a degree. So we want to find angle C, and we could do it with either the law of sines or the law of cosines. I think the law of sines is a little easier, so let's use that. Now, the law of sines relates the ratio between an angle and the side opposite that angle. And it says that the ratio between the angle and the side opposite that angle is constant for each angle in the triangle. So the sine of angle C over the length of the side opposite angle C, so 6.83, equals, now I'm going to use angle B and the side opposite angle B because I have both those values. So this is the sine of 38.9 over 4.64. And now, if I multiply both sides by 6.83, I get the sine of C equals 6.83 times the sine of 38.9 over 4.64. Now, if I want to find C, if I want to find the actual angle, I need to do the inverse sine of both of the sides of this equation. So the inverse sine of that equals the inverse sine of that. And the inverse sine and the sine cancel each other out, so we're just going to get C equals the inverse sine 6.83 times the sine of 38.9 over 4.64. Then once again, making sure that I'm still in degree mode, I am going to do the inverse sine of, and I need to make parentheses for the top, 6.83 times the sine of 38.9 degrees. So I closed the sine. Now I need to close the top of this fraction and then divide by 4.64, and now I'm going to close the inverse sine. And I get 67.6 degrees. Now, when I plug that in up here, 67.6 degrees, a bell should go off in my head saying, hey, angle C is an obtuse angle. It can't be 67.6 degrees. And that's when I have to remember that for anytime you do an inverse sine, it's going to return an acute angle value. But in real life, there's really, oh man, I can't draw a straight line, can I? There's really two triangles. And this angle here is 67.6, which means that this angle here is 67.6. So in actuality, angle C is 180 minus 67.6, which is 112.4 degrees. Alright, so we found angle C. Now, use any method you like to find the measure of angle A. Well, the method that's easiest is the fact that all three angles add up to 180. So I'm going to do 180 minus 38.9 minus 112.4, which is 28.7. So angle A is 28.7 degrees. So go ahead and take another break, stretch a little bit, have a snack, and come back for the last part of this test prep session.